Okay, we'll get started, okay? Today we are on the week 5 on program design and analysis. This actually in balance is chapter 6, okay? But we will add a few things for one dimension array from chapter 7, okay? Because that next week is actually a much bigger chapter, okay? This week's chapter is smaller. Okay, anyway, let's get started, okay? So today our topic is program analysis, design and analysis. This one is basically talking about software development and object-oriented design and has a relationship. Pretty much this is the main topic, okay? So it is a kind of more conceptual. It's more conceptual than other chapter. And then we add some material for the next chapter for array and array list, okay? Because an array, one dimension array, okay? Because next week is too big. Okay, first thing is that you need to know about the software development life cycle. And this chapter is related to the software engineering and software testing, okay? So software engineering, you first need to know about what is software engineering. Software engineering is the engineering discipline to create software, okay? Your engineering discipline to create software is called software engineering. So basically it's from the idea of creating a software to analysis, to design, to developing, to maintain software, okay? All the way from idea to product. It's called software engineering, okay? It's not just problem solving, okay? Problem solving is for computer science, but when we talk about software engineering, it's everything that related to the creation of the product for software. We call it software engineering. So over the years, many of the development models have been used. And the first one you need to know is SDLC, software design lifecycle, starting from requirement analysis, design, and then implementation, and then testing, and then deployment. Deployment means that you send it to the website or you send out as a CD-ROM to dispatch it. Then next one is the maintenance of the software. So you also may have this waterfall model from requirement, design, implementation, testing to maintenance, okay? You need to remember this word, waterfall model. So software development model, including the prototyping, incremental development, and rapid application development. So prototyping means that when you need to design a final system, before the final system can be built and tested, we build a prototype, a smaller system or a basic system that to support the idea. This is called prototyping, okay? Incremental development means that when you actually design the software, you design bit by bit. You design one component, then another component, and then another component. That's called incremental design. Rapid application development, this one means that how to develop the software in a quick way, okay? That's called rapid application development. Okay, so here you also have agile software development and waterfall model. Okay, first one is the specification. So a program specification is describing the result that a program is expected to produce. So basically a spec is a contract between the user and product managers, the company. There is a contract, we call it spec. This we call it product spec, okay? And then your manager would have another spec with the engineer that we call it design spec, okay? The product spec is the contract between user or the client and the manager, the company. This actually is a contract, means that you need me to do this, and I would like to do it within a certain time to finish it, to generate a product for you. So that become a contract between your user and manager. While the design manager means that, okay, this is a piece of software that you agree with the customer. So the engineer will implement it one by one, and then which one that should be designed in which way, that is the design spec. So these two specs are slightly different, but they all work as a contract between the client side and the engineer side. So a client use the spec to guide his or her use of the program, while a programmer use it to develop the program. Okay, so this is a concept. So basically, when the contract is missing something, you need to go back to your user or go back to your manager to figure out what should be done. Okay, so program spec. System design. Okay, so program design, it may be small scale, then you can program it in quickly. Otherwise, you may go top-down design or bottom-up design. Okay. And implementation, you can also do top-down design or top-down implementation or bottom-up implementation. But usually in software engineering, we actually prefer top-down design and bottom-up implementation. That means you design the software from the system aspect to break down different smaller components. But when you build it from a small component, and then making them work together to build a larger system. That's called bottom-up implementation, but top-down design. So here we have a top-down design versus bottom-up design. Okay, so top-down design, you start from vision to design to development. Bottom-up means that you have a library, let's use it, and then let's modularize it, and then let's use this different module to solve the problem. This is called bottom-up design. Okay. Okay, and then you may use a pseudocode, and in APCSA, no pseudocode will be tested, but CSP yes, but right here just as reference. So flowchart, you may need to design a flowchart for a program. But again, in CSA, we don't test the flowchart. Okay. And then UML is also a documentation. So far, this is a pseudocode, flowchart, and UML. These are all the documentation that we will generate for the product or design spec. Okay. Actually, they are the language to design the spec. Okay, design methodology. First, you want to have a procedural abstraction. So you break down the system into subsystems and subsystem into functions. And then in the functions, you actually have the interface for the function. And then you assign each function for some engineer to write. Okay, for example, you know that you are going to create a function that computes the power of some number. So you need to give them two numbers, the base and exponent, and then you will return the value of base raised to the power of the exponent. Okay, so something like that. And then data abstraction is when you actually hiding your data into an object. We call it data abstraction. So you only know about this object, but it has a data field, name and ID. Okay, then that probably become a user or student object. Okay, this data abstraction. So object-oriented programming talking about a different feature for the software, including data abstraction, encapsulation. Encapsulation means a private data field and public methods. Okay. And inheritance and polymorphism. This is a relationship versus has a relationship. Polymorphism is dynamic binding. Okay. And also these are the object-oriented programming. So object-oriented programming is also a software development paradigm. So it actually is also something that this chapter will test. So these are the classes and objects. Okay, the classes like this, you can create different kind of object that actually using the different classes. And in this chapter, they will test you what class need to be designed and what kind of function need to be there. Okay, the problem may test that. Okay, object-oriented programming design, you actually identify the classes. First, you identify the class, what classes is needed, and then identify the behavior, what function is needed for each class. And then you describe the is a relationship among the classes. Okay, and then you write a public method header for each class, and then you implement each function. Okay, these are the flow to do object-oriented programming. Okay, so example number one, if you are to write a program that actually maintain the inventory of stock item for small store, then let's look at the nouns. You may have inventory, item, and store. So your basic object is stock item, and then collection is inventory. So this apparently you have a class called inventory, and then that has stock items. So maybe there is an array or array list of stock items inside the inventory class. And then store is another class. Store may has a inventory. Okay. And then there may be a module to do display of the system. And then this controller actually also control the display part. So this is roughly the classes and object that we need to have. So usually you may need to use some sort of design pattern, and a very popular one is this one called model view controller model. So program number two, if we want to simulate a game of bingo, there should be at least two players. So there's a player as announced bingo game, and then there's card and caller. So these are different nonsense, and you decided to have a class called bingo card, another one called caller, and then your bingo card. Actually, you may have a players. Players may be an array of players, and each one of them have a bingo card. Okay, and then the main program is called game master. That's the class you need to have, and you also have the interface class for bingo delay. It's display. Okay, so this is the analysis of the classes based on your nonces. Okay, based on your nonces. Okay, so right here, third one is a poker game. So you have the deal, hand, format, desk, and card. Okay, a basic object class, and deck have an array of cards. Hand has an array of cards. Deal has an array of hand, maybe 4 hands. Dealer has a deck and a deck or several deck of the card. Okay, so this analysis of the classes needed. And then next one, you need to identify the behavior. Behavior usually is the verb in the sentence. Okay. Okay, this one, okay. So next one, you need to know about the is A and has A relationship. Just use the concept of is A and has A, you will figure out whether it should be is A or has A. Okay, this part is easy. And then you can have a UML diagram to model your and record your data. Okay. Okay, so right here, one example, you have a player has a game board and a scorecard, and the player inherited by good player and bad players, and good player has tutor. Okay, so this one is one example of the relationship of different classes. There has a relationship and is a relationship. Okay, and then after you finish designing the different classes, then you start to implement your class. Okay, implement your class and write your functions. So that's you use a top-down design or bottom-up design. Okay. Okay, this portion we don't waste time. We will look at the problem. Okay. This fellowship. Okay. Anyway, after you design your software for each function, then you want to do testing. Testing first, you need to prepare your test data set. Okay. So test data set, you need to know about. Okay, before you test, you need to know about. You may do unit test, end-to-end test, integration test. Okay, starting from unit test, integration test, end-to-end test, and UI test. Let's assume that you're testing your cell phone. So you test certain function that's actually is unit test. Okay, that's unit test. But you may work on the cell phone. So you test on single cell phone, that's called integration test. And then you may test two cell phones talking to each other. That's called end-to-end test. Okay. And UI test is the final test for the full-blown product of any possible situation. Okay. Any questions so far?
No.
So if you want to test a insertion value to the correct position, and you already have the data of 259, you want to test it, then you need to test the data on the point and the data in the region. So totally there are 4 regions separated by 3 numbers and 3 boundaries. So there are totally 7 points. At least you need to test. That's the test data, minimum test data for 100% coverage. Is that okay?
Yes.
It's something that you need to remember. Ellen, are you okay so far?
Yeah.
So there are 3 types of error: compile error, that's actually you have a syntax error, that's called compile error. Runtime error means that usually you don't if you don't see the problem, but when the program run and certain situation, maybe index lower bound, maybe division by 0, maybe null pointer, okay, maybe type mismatch. This different kind of the problem that actually is a runtime error. And the last one is you don't catch the error, but you do not get the result that you expected. That's called logic error. Okay, so 3 type of error you need to remember. So there are alpha test and beta test. Alpha test is a test by the company's engineers or fellow employee in the same company. Okay, before your software go for beta test, you need to do the alpha test in-house first. Then after you finish that, you actually push your product for public testing. So you actually recruit 3,000 people worldwide to test your software. That's called beta test. Okay. Okay, program maintenance and version control. Okay, whatever. Okay, before we go for the one-dimensional array, this chapter is really short. Let's look at a problem, okay? So let's look at problem, and this time let me get started from Xavier. Xavier, you go first from bottom up, okay? Hi, Xavier, hear me?
Yes.
Number one, what is the answer? So you write a program that will read the 5-digit number, maybe 1, 2, 3, 4, 5. Or can you enter 0, 1, 2, 3, 4? Can you enter that? There's a question mark. So you don't know what should you do? A, B, C, D, which one? What should you do? Hello? Which one?
E.
You don't know. You already checked with the author or the manager or the user, okay? To check the spec, maybe spec is wrong. Number two, let me have Helen. Helen, you number two. Tell me 1, 2, 3, which one is right or wrong? Helen, hear me?
Yes.
So
One
this, mhm.
one is right because like it's a 3-digit number, so it would make sense to put it in a 3-digit number class. 2 is
So
also
for,
right.
okay. For which preceding program description is a 3-digit number class, okay? Remember this is that. A, you say is okay?
Yes.
So test there are at least one 3-digit integer whose value equal to the sum of the square of each digit. So it's actually you have a 3-digit A, B, C, and then you'll be equal. So it actually is 100 times A plus 10 times B plus C should be equal to A squared plus B squared plus C squared, right? This one is to test that.
Yeah.
So suitable, that's actually okay. Second one, we use
This one's
mhm.
this one's also suitable because it's testing something for like another 3-digit number, like a 3-digit code.
Yeah, you use 3 number and see if it pass. Okay. A third one,
I don't think it's suitable because there's capital letters in it, and letters have nothing to do with the 3-digit number class.
so that's actually not related. So this is wrong. So the answer is 1 and 2 D. Okay.
Yep.
So it actually is testing that whether your 3-digit number actually is so-called coherence. It is the reaching the spec or not. In fact, if you really want to put a password that actually is a 3-digit and 3 capital letter into it, and you design the data as the string type, I think you still will pass the compiler. But you violate the rule of coherence because you are designing for 3-digit number, not 3-digit letters. Okay, so that is not suitable. Number 3, let me have Elaine, number 3.
For number 3, I think it's E because top-down programming is going from like the broadest thing to more specific things.
You say E,
Yes.
write a program in terms of operation to be performed and refining this performed by adding more details. Okay, let's see. Top-down programming illustrated by visual file. Write a program from top to bottom in Java. Maybe keep it. Write an essay describing how program work. This is a essay, it's not the coding. So this one I think is wrong. using driver program to test all methods in order to that they call in the program. The driver to test all of the program. This is nothing. This is testing method. This is nothing to do with top-down design. That is wrong. Write and test the lowest level method first. Combine them. This is called bottom up. So this is also wrong. We have A and E left. So E write the program in terms of operation to be performed. Then refine this by adding more detail. Okay, this one actually E is a better solution than A. Okay. E is a better top down from top to bottom in Java. This is so-called top down is a hierarchy. Actually, it breaks down from bigger one to smaller one. That's called top down. Okay. It's not really the line 1 to the line 7. Really not doesn't really means that. Okay. So number four, let me have Benjamin. Benjamin, you number 4. 1, 2, 3. Tell me one is right or wrong. 2, okay, 3, and then
One
when
one
you,
should be right. One should be right.
Mhm.
Because well, runtime, you have runtime errors and all that. So you'd want to have a algorithm that's quicker. And then number 2, pretty sure also should be right. Because yeah, because if you want to keep it as low memory as possible, otherwise some computers might not be able to run it. And then number 3, the ease with which the logic can be understood. I guess from a designer's,
This also be right. Okay. So basically answer is 1, 2, 3.
it's
Basically you write program, you want the time, you want the memory, you also want it to be readable. So all 3 are related to what people want to have. Okay. Number 5, let me have Xavier. Go back to Xavier, number 5. There's a number sorted in an array 1, 2, 3, 5, 7. Okay. It maintained in a sorted order. So basically, which are the following is true. Inefficient. Okay, now I'm sorry. Which one is inefficient?
3.
1 efficient?
Yeah.
You just take the first 5. So 1 efficient. 5 maximum. Maximum is maybe the last
Yeah.
one. Insert and delete a number. Okay, this one you actually need to move the data back and then insert it there. So basically 3 is inefficient. So only 3 only that's actually B. Okay. Number 6, let me have Helen, number 6.
For 6, I said A.
So you have a robust program. Okay, A, do not allow execution to proceed with embedded data. A is not, okay. Why is it not?
I said A because, like, if you have invalid data, it shouldn't throw an exception. It should say something like invalid data, try again. But this one is like, do not allow execution to proceed. So I thought that meant it would
Okay,
like throw an exception.
let's keep it, okay? Maybe that's actually not as, how about B? Another correct and
B is good, so like you do want it. C is also good.
no, the answer is C. You have a
Oh,
robot program. It did not need to run on any computer without multiplication. Your program run on Intel, but do not run on Mac. that actually is okay. It still is a robot program, but you do not actually, actually you should allow it to, even if it cannot run on Macintosh, that means that it is not a robust program.
Right.
Okay. Do not allow execution means that you use logic to bypass them. Don't let them go to your program. That is a robust program. Actually, it is a robust program. Okay.
Yeah.
We are not allowed division by zero. Okay, that actually you can use if then else to protect it. Will anticipate type of error. Okay, whatever is actually okay. The answer is C. Okay.
Okay.
Number 7, let me have Elaine. Number 7, Elaine. So there's a freight company, and then you do this. A master of programmer do shopping. Okay, which are the following you need to do testing?
To test it, you need to like test each like parameter. So
Mhm.
you have to have something less than 10 tons
Mhm.
to test the first the $80 per ton thing. And then you need another value between 11 to 25 tons, I think, to test the $40 per ton. And then one over 25 to test
So which one?
the last condition. So it would be C
C,
or yeah, I think so.
C or B? C or B or D?
Well, then it'd be over, wait, sorry, it'd be B, I think. Or
B?
yeah, because you're testing for the smallest set, right?
No, you need to test the
Okay.
boundary and the region. So you test here, 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 and on the point. So the answer is C.
Okay.
Number 8. Number 8. Let me go to Benjamin.
Yeah.
What's wrong with this one?
Segments.
What kind of error this one has?
Assumption is that it would have something to do with the PEMDAS at the end, and 4 divided by double 4. Say logic? Yeah, once oh, yeah, I think yeah, I think it would be A, logic. Can't
What does it mean by logic error?
the double 4 doesn't make any sense. Like the ending doesn't really make sense, I guess.
Then why you pick A?
Because the ending doesn't make sense. It has no
Double 4 doesn't make sense. Double 4 makes sense. Why double 4 doesn't make sense?
I mean, okay, so like I said, I think so N4 divided by double 4 would happen first because of PEMDAS.
Yeah, actually, the wrong thing is that you forget to put the parentheses on here.
Okay. Yeah, so it would just do N4 divided by double 4 first and then add N1, N2, N3.
Yeah, but if you missing this, what kind of error it is?
Syntax? If you're missing the print, what? If you're missing the parentheses, then It's either A or D for me. I'm pretty sure it's A.
Why is A? I sound like you are pretty not sure it's A because you're still switching between A and D. You are not sure. You are not actually sure that it's A. So which one it really is? And tell me the reason. So far, you are just jumping around, trying to answer something. You do not have a clear idea of what it should be. Syntax error. Is there any syntax error here?
No. No.
No, it's actually gone. Will it get the overflow?
No.
No. Will it get a type mismatch?
No.
No. Will it get the runtime error?
No.
When will runtime error happen?
Like when something isn't computable, I guess. Or I don't know how to
What
describe
do you
it.
mean by not computable? Index out of bound division by zero, we just talked about it a moment ago, so there's nothing like this. So it's logic error, but why logic error?
Because is it because n1, n2, and n3 are integers in this case?
No. So you still don't get it. Logic error happen when the result is not what you expected. You want to do this kind of thing and you should get some result, but the result you get, there's no compilation error, no runtime error, but the result is not what you wanted. Then it's logic error. Okay? Number 9, let me go back to Xavier. Xavier, number 9.
D.
When will this oversight be detected by computer? So what that is the oversight? A program evaluates binary expression from the input. All the operands are these. In writing the program programmer forget to include the test that check the right-hand operator, or you forget to check division by zero. So if you have a division by zero, what kind of error it will be?
Runtime.
Runtime error. So it's B. Okay. Is that okay? Number 10, let me have Helen.
The first one I said would work because it's like a get move method, so it's like it could be an integer. Like the second one I also said would work because you're like removing a number of chips, so that could also be like an integer. The third one I said wouldn't work because it's like a tic-tac-toe grid. You can't really do one integer to simulate a move.
So what
my
can you
answer
do?
is D.
So what can you do?
For the third one,
What should you do with the number 3? So 1, 2, you can return integer, yeah, and then 3.
you could like find some way to put the two coordinates in one number, like 1, 0, 2, if you wanted to put an X on like 1, 2 or something like that.
So here you say you return 2 numbers. So you have let's assume here you have a 3 by 3. So row and column is 0, 1, 2, 0, 1, 2. This one is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you basically use your row times column plus row times 3 plus column number. So this integer still can represent the array location. So this problem actually, the book want you to pick 1 and 2, but 3 actually is arguable. You can still use one number to return.
Okay.
But because we are kind of this a little bit extra soft, so we actually stand by the solution given by the book on this one. So this one I should say is a little bit of a technical error by the parent. Minor mistake, not a major mistake. That means that they intended that people don't return in simple integer. They should return the row and column. But in fact, the row and column can be coded into a single integer as well. So it's kind of questionable, okay? But since the purpose of the book author would like to do, so we pick the only 1 and 2, okay?
Yep.
So number 11, let me have number 11. Precondition. What is the precondition of the method?
So a precondition is like conditions that must be true before like the method is ran. So out of all of them, I think A describes it the best.
Describe precisely the condition must be true at the time the method is called. Second initial parameter, okay, A is closer. This post condition wrong. Explain how the method does know is the functionality of the program. State that the initial value or local variable it must be actually no. Okay, so this one is A, okay. Number 12, let me have Benjamin, number 12. You have these, and then from the algorithm to initial setup of A1, A2, A3 or cost, which one? Okay. Which one will give you the best case? Which one will give you the worst case?
Best case would be best case would be just finishing it off instantly. So that would be largest value in A1 or A2. That's for the best case. And worst case would be going all the way to the going all the way to A3. So I'm pretty sure the answer is A.
So worst case happen when your A3 really greater than max. So you have one extra line you need to run.
Yeah.
So this one can only be this and this, okay? Now you actually pick these two and then you would like to see which one is the best case. Best case A greater than 2, okay, so basically larger value in A1, largest value in A1 or A2. This one will give you the best case. Okay.
Okay. Yeah, so that the answer will be A.
Okay. This one actually, this one A greater or B greater, it doesn't matter actually. It is the same amount of time you will run. So this one is actually check the answer, okay? It's number 12. Non-terrestrial. It's A, okay, it's pick A. I have a question about A because A1, A2 largest one or not. I don't think there's a difference. Okay, so when they design this program, the part one actually, I don't see anyway. Or best case actually means that you don't go into this one. Best case means you don't go into this one. So actually, larger one is A1. Okay, so A is correct. Okay, I'm sorry. Actually, yeah. Beta case, that's that. This one is 13. 13 go to Xavier 13, Xavier. So what is the precondition for the while loop?
It has to be like,
Hmm?
it has to be true for the while loop to run.
Yeah, but what is the precondition? No. So how to answer this question? My problem is how to answer this question.
Like you look at
N is an integer greater equals 1 to be initiated.
what's the difference between C and D?
That's my question. What's the difference between C and D? You have to have a logic of picking the solution. So between C and D, which one you pick? And why? That's a question I need to ask you. Precondition means what? You set up a condition for this. So here you already say that N need to greater than that. So you should have this one. K equals 1, that's also precondition. Sum equal 1.0, so still complete. So the answer is D. So precondition, why you assuming K less than N? Who assume that? Why you will assume this? It's not, no one assume that. No one assume that K will less than N. No one assume that K will greater than N. No one say that. This one may be the function of the for loop, but that's not precondition. This one is the final result. This is also not precondition. So precondition is a condition that you set up before you go into the loop. This one is the statement right here. They want it to be happening, even though there's no setup, but that's the precondition they want. That's a precondition. Okay. Number 14, let me have Helen, 14 Helen. There's a Fibonacci function, I think.
I said C
So
because
which of the following correct assertion about the loop variable I? Loop variable I is right here. So I's value is greater equals 3, less than equals N, right? C, right?
yes. Yes.
Number 15, let me have Elen. Number 15, Elen is a mystery function. What is the post condition? So when it finishes, what would be the total? That's what it means.
For this one, I think it would be D, A times B, because like after running
It plus
through the
A plus A plus A and then totally plus B time. B
Yeah.
is counter, the counter count from 0 to B. So totally is A times B. Okay, so the answer is D, okay? Number 16, go to Benjamin. This is an object-oriented programming problem, okay?
Yeah. Copy the in. We should have. This is a reasonable choice to be responsible. 2 and 3. One wouldn't work because there's a very good chance that they purchase more than one item. So just using one item wouldn't work. So it would be better off to put the whole list of actually because the item list will just store multiple items, which all of them have the quantity, the unit price, and the total price. So
The answer
answer
is 2 and 3, okay?
Yeah, that's
Either way you put the amount due there is okay, because
Yeah.
you calculate total amount of the cost. Number 17, go back to Xavier. Which one for OOP is true? False, I'm sorry. They want to pick false. It's wrong.
C.
C, is A and has A usually don't happen in the same at the same time. So you cannot say that is C is A2, C is C2, and then is A C2, and then C2 has A. That's wrong. Okay. Number 18, go to Helen. I cannot have the total. Let me make it smaller a little bit. Okay. So number 13, 18, there's a Java program doing this. And then which is a bad choice?
I said B because like it doesn't make sense for the tire. Like the tire is a circle, but I don't think it should extend circle.
Tire is a circle. Tire cannot extend circle. Why?
Because it's not part of the circle class. It's something that uses a circle. So I think has a relationship would be better.
Tire extend circle is fine. You have a circle. Circle has a pi r square, the radius, and then something like that. So tire inherited that actually is okay. Why not?
Honestly, most of it was like process of elimination.
Hmm?
It was kind of process of elimination. Like I saw A, C,
So
D, and E.
V equal has tire. That's okay.
Mhm.
Have a steering wheel. That's okay.
Right.
Car extend vehicle, that's okay. Tire has a rating and circle boundary, that's okay. Steering wheel, ABS and circle boundary, that's okay. So this one is a little bit ambiguous. I would say A, B, C, D, E, all okay.
Mm-hmm.
But it will give you the answer of B. If they use the logic of the what they are being consistent by themselves. The tire has a circle, not tire extend circle. That's what they want to show. But to me, that's still not clear. You still can use a tire to extend circle. You still can do rectangle and poker car extend rectangle. That's actually still a okay choice. You know what I'm saying?
Yeah.
So this one, if I need to answer, it actually is no answer. Okay?
Mm-hmm.
But the book give you the answer of B. This one is ambiguous, we should say. Number 19 is Elen. There are several classes, a lot of classes. So which class you should implement first?
Out of the options, I think you should implement the independent classes first because they are like dependent on other classes, so they can be like
They are what?
tested by themselves.
They are not depending on any other class. Also, nobody depend on them. So basically, you test them first. Yeah. Number 20 to 22. This actually is a group of question, but let's get started for 20 for Benjamin. Here you have a bumper car video game, and there are these different nouns. So how many nouns should be immediately discarded? You do not need it for class. So which one you don't need it for class when you see these different nouns?
Hmm. Suitable.
Immediately, it means that you look at it, you already know that this one we don't need it.
Integer.
Integer, yeah. And then
No, you need bumper car. A random direction? Direction since
direction, you have a reverse direction, and yes, direction maybe you still need to immediately swap means that you know that it already don't need it. Direction you may or may not need it.
I can't really see anything else that's like a may or may.
Program you don't need, right?
Oh, okay, yeah.
Why do you need a program? Program just that you write a program, just announce that it's not related to it.
Yeah.
Simulation maybe, maybe not, okay? So this one, number 20 is C.
That would be 2, I think.
That could be 2. I think it's the
Yeah.
program and integer, okay? Is that okay?
Yeah.
That's what I think. Because simulation, maybe not. Once it is maybe not, it's not immediately discarded. We say immediately means that you see it, you know that's not related to the program. The program word itself is not related. Integer is the data type is not related. Okay, you immediately know these 2 terms, you are not going to put it in the classes.
Yeah.
Number 21, go back to Xavier. So this one, there is a simulation display, whatever, which operation responsible for is not responsibility of grid point. So grid point don't have which function.
A.
A is the empty return force. It actually is a grid point. It actually is a point class. You have the whole grid. Grid contain grid point, and each grid point may have a car on it. So A is empty. Should be needed. Okay.
I think because like it says it's represented by X coordinate and Y coordinate. So
Okay. So you don't have the car information. That's what it is. Boundary, you make okay, up, left, and get X is okay. It's all related to XY. So this one not related to XY. Okay, good. 22, let me have Helen, 22. Which is not suitable for bumper car class.
I said E because that's the whole grid, and bumper car class doesn't need to update the whole entire grid.
Okay, that's a different, that should be in the grid class, okay? Okay, so we finished this one, chapter 6, but because we have more time, so we are going to go over the array. Okay, let's go over the array. So this is actually next week's review material, but because next week is too huge, so we are going to go over one-dimensional array today, okay? So one-dimensional array, before you go for one-dimensional array, you actually should look at the reference type. So array is one of the reference type. You have array, class, and string in Java, okay, for AP exam. Array usually is a pointer, reference value is stored in the stack, and then the array body in the heap, okay. So this different ADT material, you have string, array, okay, this is right here, and then this two will be the next week, okay. And this is 3 actually is in the chapter 7 of the parents book, okay, but I actually talk about array today. So array list and two-dimensional array. In what situation, what you need to do is array list. You need to, when you have your data need to be flexible length, you would like to use array list. So how many friends you have, the number of friends should be changing. So you would like to use it. Number of phone call for the message is also changing. So you want to give it like that, okay? Number of elevators for the floor is fixed, so it's array, okay? A program keep track of the classes you have each period of the school day. So it's period 1 to period 7 is fixed. So that also is array. Two-dimensional array when you need to have a graph, okay? You do that. That is a basic difference. So array definition is you declare a left-hand side array reference, right-hand side new an object in the heap, and references store the starting address of the array, okay? So if you do predefined arrays, integer, int, AR, array with this, but remember if you do integer array, A, and then later you do A equals, then you cannot do this. You cannot do 1, 2, 3. This is wrong. You cannot do that. You have to write A equals new integer, bracket, curly brace, 1, 2, 3. Is that okay so far? It's one thing you need to remember. And then you need to know about how long the array is, okay? And you actually, okay, when you assign it, you need to do that. And then array length is the number of elements. So usually if you have 10 elements, 10 means 9 included, okay? The first element, so basically if you have the first 3 elements, it should be from 3 to 3, but not including 3, okay? Last 3 elements will be starting from n minus 3 to the end of the array, or n minus 3 to n. That's the last 3 elements. Any questions so far?
No.
So array, most important part is the index calculation, okay? Okay, this parent reference, we don't talk about it. So these are basic array operations that you need to have, okay? Need to remember this different one. Finding maximum, minimum, reverse of the array, any sequence, okay? This different algorithm you need to remember. So your symmetric location, number of the element, okay? Number of element, if you with A element is just from 0 to 7. So you use your A minus 0. Okay, if the n index not included, then it's okay. And if you are using the last one's index, it's the last one minus the first one index plus 1, okay? N index means the one that is not included. Okay, so sometimes you need to know about the base and the running index, okay? The running index. Okay, let's do this later, okay? Let's do this. This one, let's actually first talk about the use of the BlueJ. Still, students don't know how to use the C double plus A double plus well. Okay, one more time, we would like to talk about the running index. Let me delete the with file, okay? Let me see. Make a mistake. No, this one actually. Okay. We should go to the, not here, it should go to BlueJ. Okay. So right here, let's put the, let's choose this one. Okay, right here. And then let's choose with file. Okay, so the running index, a lot of students still not actually good on it. First one, that's actually set up an array. Let's assume that the data is okay, let's assume the array is like that. So if we want to get the first three n element, okay. So here let's do public static integer get first. Okay, you got an array of A, you want to get the first n letters. Okay. So you want to get a first n later. So if n greater equal to greater than a the size, a the length, then you return null. There's no such thing that you can do. Okay. And then otherwise you will create a new array, integer array R, that's new integer array with the n element. And eventually you are going to return this R. And you want to copy the first n number to it, so you do for integer I equal 0, I less than n, I increase, okay, and then r's I should be equal to a's I. So this one no problem, okay, no problem, it's quite simple. So I don't hesitate, this one you to get the first n later. So here, public static, okay, integer array. Get, okay, let's assume that you have an A array. You want to get from start to the end. And then this one, let's assume it actually is inclusive. So the ending one is need to be included, okay? So if start less than 0 or n greater than a length, okay, then you return null. These two cases, you return null. Okay, there's no thing you can return. Otherwise, you return a R array that's new integer from end to star. So it's n minus star, but need to plus 1 because n is included. And you return R, okay. So this one you will from start. So for integer I equal 0, I less than R the length, I increase. Okay, so here R I should be equal to your A star plus I. Then you copy from start to end to the new array R. Any questions so far?
No.
No. Now, if we have a array that you will copy from start to end to another arrays, this A, this is B, you will actually copy it to starting from star 2. Okay, then what should you do? So publish static integer. Okay, this one is void. Okay, you actually do trans copy from array A to array B. Okay, integer from star 1 to integer end 1. Okay. and then you copy to integer *2. Okay. So basically you do if, okay, if *1 less than 0 or n1 greater equal to a times, this one you do not have the right range, you return null. Okay. You just return, you do not say. Okay, otherwise, if your *2 less than 0 or your *2 plus n1 minus *1 plus 1. Here you have the *2. You are going to copy totally n1 minus *1 plus 1 number to it. Okay, so this is 0. Go up to this one's totally is n1 minus starting 1 plus 1. Okay, so here the last one should be 0 up to n1 minus s1. Okay, so the last one's like that. So basically you start 2 plus minus the *1. This one is actually the last index. Okay, the last index. So this last index, if it is greater or equal to actually be the length, then you are out of bound. So you will also return, you are not doing any copy. Okay. Other than that, you are going to copy from *1 to n1 from A array to the star array. Okay. So integer p should be equal to *2. Okay, and then for integer I equals *1, I less than equal to n1, I increase. Okay, these are going through the every data. So your A's, I's value will copy to B's P plus value. Is that okay?
Yeah.
You starting from this and then you actually increase. Okay, I'm sorry. This one actually is, you will just return. Okay, this one actually this one no return. I'm sorry. This array you do not have return. So this is no return, you don't need that. That's good enough. Okay. So this is some sort of transcopy. Okay, you need to use the transcopy well. Now, if we want to do a two-dimensional array, you want to copy it to one-dimensional, okay? This one you still need to review it, okay? So let's do this one. You are going to copy 2D to 1D, okay? So you have a integer 3D array M and 1D array A, okay? So this one you should do for integer I equals 0, I less than and length. I increase. And for integer j equals 0, j less than M, I length, j increase. And right here, remember you need to qualify it. So so right here you should have integer p equals 0. Okay, if p less than 8 length, okay, then h p plus plus will be equal to m ij. That's it. This one you will copy from 2-dimensional to 1 dimension. Okay. Then there's a question that you actually have a few number, and then you want to put a number up to the last 4 to a new array. Okay, there's a problem like that in coding pad. Okay, so this one, if you want to copy that all the number up to the last 4, assuming that you do have a 4 somewhere in the array. So you need to know about how long this one is. Okay, you need to know about. So you will find the index of a 4 first, and then this one is n. So right here, how many of it? This is n minus I plus 1, minus 1. Okay, so n minus I is this many. You just need to minus 1. Okay, so let's do it. So integer p equals 8 length minus 1, starting from the last one. Okay. So while p greater equal to 0 and a's p not equals 4, then your p decrease. So p decrease when p will stop at the equal 4, or p is less than 0. Either way, okay, either way is fine. So then you may end up here, or you end up at a certain 4. Okay, then you calculate how many number you would like to copy from here. So that actually your integer array R should be new integer array A length minus P. P is the 4th location, and then minus 1. Okay, that's the total number of the element in R. So your next one, you set your pointer P would be, let's use another number. Let's use Q equals starting from P plus 1. Okay, that's the location that you will start to copy. Okay. No, this one actually, let's set Q to be 0. So for integer I equals P plus 1, I less than A gallons, I increase, then your R's Q plus plus should be equal to A's I. And eventually you will return your I. Okay, this one is just copy all the element after 4. You need to first find out your 4's location, where your 4 is. And then the one after it is the number that you start to do copying. Okay, but your new array will start from 0. So your Q is the pointer to new array, is Q plus plus. Okay, any questions so far?
No.
Okay, so anyway, we try to teach you different kind of transcopy for one-dimensional array, okay? Any questions so far?
No.
Okay, today's chapter is shorter, okay? So next time we work on the arrays and two-dimensional array, okay? And then one more time, please return your homework, okay? So far, still very poor performance. Now this one. That's the AP concept principle. Students still not practicing. That's actually a big problem, okay? That's actually a big problem because time is running out. If you don't practice, you don't get someone to help you to correct, you are in big trouble, okay? Please work on it, okay? That's the only thing I can tell you. I would say this year's student probably is the worst so far. I've been teaching more than 10 years. This year's student is probably the worst so far, okay? Not a lot of students returning anything. Please work harder, okay? That's the only thing that I want to say. Okay, see you next time. Bye-bye.
Bye bye.
Bye, thank you.
Thank you. See you next